Hello everyone. Welcome to Devon Education Hub. Learn, build, and innovate. Let's get started.
Have you ever watched a commercial jet lift into the air? Or, closer to home, how a folded paper airplane glides across a classroom? Humans didn't invent the concept of flight out of thin air. Long before airplanes existed, we looked up at the sky and studied nature's original flying machines, birds gliding effortlessly over the ocean. Think about the last time you folded a paper glider. Maybe you noticed that one design sails perfectly across the room, while another instantly nosedives into the floor. Why does that happen? It turns out flight follows a specific set of invisible rules. By turning our paper planes into a simple science experiment, we can uncover the exact same physics that keep those massive jumbo jets in the sky. Every object that flies is caught in a constant invisible tug-of-war. There are 4 distinct forces pulling on it at all times. The first force is weight. Gravity acts like a constant field pulling everything straight down toward the center of the Earth. If you drop a stone, it falls. That downward pull is weight. To fight gravity, we need the second force, lift. Lift is an upward push created by moving air. Think of flying a kite. When the wind hits the angled surface of the kite, it pushes the kite up into the sky. Airplane wings rely on a curved teardrop shape, the airfoil. It's rounded on the top and flatter on the bottom, which is the key to how it moves through the air. This shape forces the air moving over the top to travel faster. As the air speeds up, it stretches out, creating a zone of low pressure above the wing. This pressure difference literally sucks the wing upward, while the higher pressure underneath gives it a boost from below. If the upward push of lift is stronger than the downward pull of weight, the plane climbs, but if weight wins, the plane falls. That is why your paper plane drops to the floor the second it stops generating enough upward lift. To keep generating lift, the plane has to keep moving forward. That requires our third force, thrust. Thrust is simply the push that propels an object forward through the air. When you throw a paper airplane, your arm provides a quick burst of thrust. But because a real airplane is so heavy, it requires massive, continuous propulsion from jet engines to keep it moving. Fighting that forward movement is the fourth force, drag. Drag is air resistance. If you have ever rolled down a car window on the highway and stuck your hand outside, you have felt the wind forcefully pushing your hand backward. That is drag. We can see how this math works on this diagram, showing all 4 forces as directional arrows. If the arrow pushing forward, thrust, is stronger than the arrow pulling back, drag, the plane accelerates. If drag wins, the plane slows down. Now apply this directly to your paper plane. The moment it leaves your hand, it has no engine to keep it going. Air resistance immediately starts slowing it down. As its forward thrust runs out, the air stops flowing fast enough over the wings. Lift disappears, gravity takes over, and the plane glides to the floor. Sustained flight requires maintaining a perfect, continuous balance between all 4 of these invisible forces. Aerospace engineers design different vehicles to balance these 4 forces, depending on what the machine needs to accomplish. Look at a helicopter. Instead of fixed wings, it uses rapidly spinning rotor blades to generate both thrust and lift at the same time. This allows it to defeat gravity and hover in place without needing a runway. Gliders take the opposite approach. Like paper airplanes, they have no engine to provide thrust. Instead, they use incredibly long, thin wings to capture as much lift as possible, allowing them to ride rising currents of warm air for hours. Our understanding of this balance started with early pioneers like Wilbur and Orville Wright, who tested wing shapes in small wind tunnels before ever attempting to fly. Understanding how these forces balance out revolutionized travel and emergency rescues. It even gave us the foundational physics needed to eventually begin our journey towards the stars. Let's review the rules. Weight pulls down, lift pushes up, thrust pushes forward, and drag pulls back. Here's a final engineering challenge for you. Looking at the 2 planes in this diagram, what would happen if you built a paper airplane with wings that were twice as large? Would it fly twice as far? In aerospace engineering, there is always a trade-off. Larger wings do create more lift, but they also catch more air, which creates a massive amount of drag. They add weight, and the thin paper often lacks the stiffness to support that size, causing the wings to fold up and crash. Science is happening right in your hands. In fact, the next great aerospace engineer or astronaut might be folding a piece of paper in their classroom at this very moment. So grab a piece of paper, keep learning, keep thinking, and
Thanks for watching. If you enjoyed this video, please like, share and subscribe. Stay connected with Devon Education Hub.